Hi, I'm Mel, and this video is going to be about how wireless infrastructure is silently leaking sensitive data through a combination of insecure, unencrypted, or poorly configured network components. So, to put this very simply, some wireless networks aren't set up securely. This can cause small amounts of data to leak without anyone noticing. Attackers don't need to do anything loud or obvious, they can watch quietly. Most security tools look for big, unusual traffic spikes. Slow, steady data leaks often slip past these tools because they look normal. Okay, and we're going to be covering a lot of different things, and you'll see a combination of slides and me talking and some images as well. Okay, but yeah, that's sort of like the basics of it, what we're going to be doing. Okay, thank you. Okay, so how is wireless networks leaking data? So how is wireless infrastructure silently leaking sensitive data? Okay, so one of the methods is unencrypted satellite backhaul. And I'm going to go into all of these terms and technologies in detail. I'm just going to get this first one out. So researchers have discovered that sensitive data, including phone calls, SMS, and internet traffic, can be intercepted from geosynchronous satellites used for cellular backhaul. The issue is that many of these satellite signals are unencrypted. Using an $800 receiver system, it is possible to intercept data from telecom providers, airlines, even military or critical infrastructure. The risk: this allows for interception of data at a national or global level, often bypassing traditional terrestrial security. Okay, so I'm going to put this, you're going to see some dot points, a slide for dot points after this video, just with exactly just to reinforce it. And then I'm going to go into what all that means. Okay? All right, thank you. Okay, so what does any of that mean and what are we talking about? So with satellite backhaul, some satellite systems that carry phone calls, text messages, and internet data are not properly encrypted. Okay, these satellites are used as backhaul, meaning they move data between remote cell towers and the main network. Okay, so backhaul is where they move data between remote cell towers and the main network. Because the signals are unencrypted, anyone with the right type of receiver can capture the data as it travels through space. All right, so unencrypted, it just means that the data is not scrambled or protected. Geosynchronous satellites are satellites that stay above the same spot on Earth by orbiting at the same speed the Earth rotates. Intercept is to capture or receive a signal. Receiver system, device that can pick up satellite signals. In this case, researchers used equipment costing around 800. Telecom providers, companies that provide phone, SMS, and internet services. Critical infrastructure, systems essential for society, power grids, water systems, transportation, emergency, banks probably. Passive surveillance, watching or collecting data without interacting with the system or sending anything back. Bypassing terrestrial security, so avoiding ground-based security systems because the interception happens in space, not on Earth. All right, so I'm going to put this in bullet points to follow this video now, just so you get sort of like what we're talking about. Okay. Okay, now that we've talked about the what we were talking about just before, which is the how like satellite backhaul can be overtaken. All right, so we're talking about unencrypted satellite backhaul. We're going to talk about exploitation of signaling protocols. So that's SS7 diameter GTPC. So mobile networks can rely on aging signaling processes like SS7, diameter, and GTPC to connect calls and messages. These protocols have inherent security vulnerabilities. So, location tracking. Attackers can track users within a few hundred meters in urban areas or a few kilometers in rural areas, leading to severe privacy violations. Intercepting SMS and calls. Hackers can use these protocols to hijack communications, bypass two factor authentication or 2FA, and drain bank accounts. Okay, so I'm going to put all of this, all those points in a couple of slides, and then we're going to go through point by point examining all of that. Okay, what it means and what's it talking about. All right. Okay, so what are we talking about? So signaling protocols are the language that mobile phones use to talk to each other and manage calls, texts, and roaming. SS7 or Signaling System 7 is a very old system used by 2G, 3G networks to route calls and messages. It was built when networks trusted each other, so it has weak security. Diameter, a newer protocol used in 4G and 5G networks. It is more secure than SS7, but still has design flaws. GTP-C or GPRS tunneling protocol or control plane, used to manage mobile data sessions, controls how your phone connects to the internet. So location tracking, it's using signaling messages to find where a phone is located on the network. Intercepting SMS calls, so manipulating signal messages to redirect or copy communications. Two-factor authentication, security codes sent by SMS or to email, usually SMS, to confirm your identity when logging in. So what's the problem? The mobile phone network systems, if they're older, they're very insecure. If they're more modern, they're more secure, but they were not designed with very strong security in mind. Attackers can abuse them from anywhere in the world. So what do attackers do? They track a phone location within a few hundred meters in cities, intercept SMS messages, including 2FA codes, redirect or listen to calls in some cases, bypass normal security checks because the network trusts these protocols. So why does this matter? Okay, people can be tracked without consent. Bank accounts and online accounts can be compromised. Sensitive communications can be exposed. Vulnerabilities affect networks globally. Okay, so that's pretty much that. I'm going to then now have a slide after this, just putting the terms in just so you get it. All right, thanks. Okay, now we're up to number 3 in this issue of wireless infrastructure silently leaking sensitive data. So number 3 is low and slow data exfiltration. Attackers often compromise a network via legitimate but unsecured access points, then begin slowly siphoning sensitive information such as intellectual property or customer data a few kilobytes at a time. Why is this silent? These leaks blend in with regular, legitimate traffic because they don't produce large data spikes. They are rarely detected by legacy data loss prevention systems, or DLP, as sometimes for short. Okay, so that can be a problem. All right, just that. We'll go into some of these terms. All right, thank you. Okay, so now we're going to talk about point 4, which is rogue and misconfigured access points. Okay, so unauthorized or poorly configured Wi-Fi access points are a major source of data leakage. So rogue access points, attackers set up spoofed access points that mimic legitimate networks, allowing them to perform man-in-the-middle attacks. And weak encryption using outdated protocols like WEP, WEP or WPA2 with weak passwords allows attackers to capture in the clear traffic from unsuspecting users. Okay, and we're going to talk about all of that and more following in the following slides and videos. Okay. Okay, so now we're going to do the next part, 5, side channel attacks on air-gapped systems. So even systems that are not connected to the internet, like air-gapped, can leak data through wireless channel. So there's what's called an air-fi attack. Malware can exploit a computer's memory, DDR or SDRAM, to generate electromagnetic radiation at 2.4 gigahertz, which then can be picked up by nearby Wi-Fi capable devices like smartphones or Internet of Things devices and transmitted to the attacker. So we're going to be discussing more in depth in the following slides of that point. Okay, thank you. Okay, so now we're going to talk about the 6th item in this, where mobile app gossiping. Mobile applications often leak personal information over encrypted Wi-Fi networks. So the issue is even when the Wi-Fi connection itself is encrypted, the patterns, timing, and size of the packets being sent allow attackers to identify which apps are being used and infer sensitive personal details like age, location, or health information. Okay, and I'm going to talk a bit more about that. in the slides. Thank you.